As we know, we are here for FortiGate Firewall training. So we want to know here that what we will cover this entire training, what will we will learn here, what will be the duration, and how we will go through. For this, you need to go to I-MEDITA website, go to I-MEDITA, go to live training, go to Fortinet FortiGate Firewall, click here, go to I-MEDITA Fortinet FortiGate Firewall Training, then go to curriculum. Here you will see course detail objectives and you will also see course outline detailed. This is the content. So first is summary and second one is here detailed. So let's go through or proceed with detailed section. Done. If you want to get it, click on browser and go to another tab, download this stuff in your download folder and then open it. All this stuff you can get in PDF file. So this is our content which we will cover in this entire training. Done. Let's continue. So first of all, we will go through with firewall introduction. And before this, which Fortinet certification we will cover in this training? Go to Google, type here Fortinet certification path, Fortinet certification, go to NSC, and here we need to go to NSC, okay, or we need to click here NSC certification, and here go to NSC for learn more, NSC for learn more. Then we have here NSC for NSC FortiOS administrator. This is our training here. NSC for FortiOS administrator training. Okay, so this is our training content. We are going to cover NSC 4 or FortiOS administrator. These are their exam topics, but we will cover more than this. Clear? So officially we are going with NSC 4, and in NSC 4 we are going with FortiOS administrator, and content you can check here, or more than this we will cover here. Now what is this? It is in front of you. First of all, we will go through with firewall introduction. In this section, we will learn here what is firewall, how many firewall techniques available here, like packet filtering, proxy server, stateful firewall, transparent firewall, and next generation firewall. We will discuss about these techniques. After knowing firewall, we will go through with FortiGate firewall introduction. Here we will learn what is FortiGate and FortiGate normal firewall features, as well as next generation firewall features we will discuss here. Then we will go with next section. Next section is here lab setup. After doing theory, definitely we will do here practicals. For practicals, we need to set up our lab. And here I will tell you that how we can set up our lab using EVNG. Okay, all the software's images we will share with you. Using those images and software, you can do practical. You can make lab at your laptop or desktop, and you can do practicals. After lab setup, we will do basics like how to access FortiGate firewall, how to enable telnet on firewall, how to enable SSH, HTTP, HTTPS, and how to verify whatever we have enabled like telnet, SSH, HTTP, and HTTPS. So after verifying these services, then we will learn how to take plain backup, how to take encrypted backup, how to configure firewall with factory default configuration, how to restore configuration, how to reset admin password, how to update firmware. So these things or stuff we will learn in our firewall basics. We will do this configuration in two approach using GUI. First of all, we will do the things in GUI, and after GUI, we will do the things in CLI here. Done. So after basics, we will move to basic routing. Here we will learn static routing, default routing, link monitoring. Static routing, default routing, just like router. What is link monitoring? Here I am assuming that you have the knowledge of CCNA and CCNP. In CCNP, we go with a feature like IPSLA. Same IPSLA is called IPSLA is called here link monitoring. IPSLA is called link monitoring in FortiGate Firewall. So we will learn how to implement link monitoring. Using link monitoring, we can check reachability with the next hop or beyond next hop. So these three things we'll learn in basic routing. Here we will also learn how to implement zone on FortiGate firewall. When we say we are going with FortiGate firewall, so it means we are talking about leaders in firewall like Fortinet, Palo Alto, and Checkpoint. Palo Alto firewall support zone. Checkpoint firewall support zone. Now question is this: does FortiGate firewall support zone? Then question is yes. Then next question is here how to configure zone on FortiGate firewall. We will learn here, as well as we will also learn here how to configure policy based on zone. So these three or four things will be in basic routing. After static default and link monitoring, we will move toward advanced routing like RIP. In RIP, we will learn implementation and troubleshooting. We will start with basics, routing table verification, redistribution, timer modification, and default information originate. Then we will learn AD changing, distribute list, offset list, authentication, and T-shoot. So this stuff or topics or points or features we will cover in RIP. After RIP, we will move toward here OSPF, basic implementation and troubleshooting with basic and multi-area, neighbor table verification, database table verification, routing table verification. We will learn virtual link, hello interval, dead interval modification, authentication, as well as here stub area, totally NSSA, external summarization, inter-area summarization, default information originate, and redistribution, as well as T-shoot. So these topics we will cover in OSPF. After OSPF, we will move toward here ISIS, implementation and troubleshooting, basics with tables verification, with authentication, redistribution, and troubleshoot. After ISIS, we will move toward BGP, base implementation troubleshooting with basics, neighbor table verification, BGP table verification, routing table verification, attribute next hop self, route reflector client, authentication, aggregation, redistribution, and T-shoot. So these topics, points, or features we will cover in our BGP. Till here, our IPv4 routing will be complete. Then we will move to next IPv6 routing like static, default, and link monitoring, RIP-NG, implementation and troubleshooting with basics, routing table, verification, redistribution, timer modification, default information originate, AD changing, as well as distribute list, offset list. So these things we will cover in RIP-NG. After RIP-NG, we will go to OSPF v3, implementation troubleshooting, basic and multi-area, tables verification, virtual link, hello interval, dead interval, hello interval, dead interval, modification, totally NSSA, external summarization, and then inter-area summarization, and then default information originate, redistribution, and T-shoot. So these topics we will cover in OSPF v3. Then ISIS v6, with same just like IPv4 implementation, troubleshooting, basics, tables verification, authentication, redistribution, and T-shoot. Next, we have here MPBGP, implementation T-shoot, basics, neighbor table, BGP table, routing table verification, next hop self, route reflector client, authentication, aggregation, redistribution, and T-shoot. So till here, our IP version 4 and IP version 6 routing will be complete. Next, we have here security and net policies. We will learn here what is network address translation, why it is necessary, types of net, theoretical and practical like static net, PAT, destination net, and user authentication with IPv4. Same thing on IPv6. So we will learn here netting. After netting, we will move to our next topic, site-to-site VPN or IPsec VPN. Here we will learn what is IPsec VPN, protocols we used for VPN implementation like IK, ESP, AH, IK modes, main mode, aggressive mode, quick mode, phases, phase 1, phase 2, ISA camp, transport mode, tunnel mode, ISA and your Diffie-Hellman group like this. So we will discuss here. After theory, we will do practical, or we will learn how to implement site-to-site VPN with version 1, with version 2, with certificate authentication and T-shoot. So these 4 labs will be FortiGate to FortiGate. But it is not necessary that always we will get FortiGate opposite side. So we have also added here multi-vendor devices like Cisco router, Cisco ASA, Palo Alto, Checkpoint, Juniper, Cisco FDD, Sophos, site-to-site VPN with IPv6. So we will also learn site-to-site with Cisco router, FortiGate to Cisco router, FortiGate to ASA with Palo Alto, Checkpoint, and Juniper FTD and Sophos. So here we will not only learn site-to-site VPN on FortiGate as well as with other devices as well. After site-to-site, okay, so before going next, let's understand what is the purpose of site-to-site VPN and why we use it. Then here we have firewall 1, firewall 2 connected with internet and lane. We have branch 1, we have here branch 2. Branch 1 and branch 2, they are connected to each other via internet. Now we want both branches should be able to communicate with each other. For this, we will configure here IPsec VPN, or we can say here site to site VPN, IPsec VPN, and site to site VPN we will configure here. Using this site to site VPN or IPsec VPN, branch 1 user will communicate with branch 2. Branch 1 user will communicate with branch 2. So this is the use case of site-to-site VPN. Using this, we can make it possible that one device in one location can communicate with other device at other location, or the lane behind that they can communicate with each other. So this is the purpose of your site-to-site VPN. After site-to-site VPN, then next we have here transparent firewall and vWire. So what is transparent firewall and vWire? Transparent firewall or vWire we can understand in this way. For example, we have a network like branch 1. So branch 1, branch 2, branch 3, branch 4. 1, 2, 3 and 1, 2, 3 and 4 here. These devices, not branches, these are the my lane. So lane connected with switch, switch connected with router. Router is connected via lease line to other router. Two routers can be connected to each other via lease line. They can be connected with each other via internet, or they can be connected with each other via MPLS VPN. What we have? We have here router. Router is configured with IP addressing. Router is configured with routing. Router is configured with netting, VPN, MPLS like this. So we have configured router with IP addressing, routing, netting, VPN, and MPLS. Now what we want? We want this thing. We want to protect our lane. To protect our lane, we will remove router. We will configure here firewall. And at this firewall, we will configure IP addressing, routing, netting, VPN again. MPLS not applicable. Then we will configure here firewall policies. So these things we will configure on firewall again. Question is this: when we have IP addressing again already, why to do it again? Routing already done, why to do it again? Netting already done, why to do again? VPN configured, why to do again? MPLS we cannot bypass. Now we don't want to remove here. We just want here firewall policies. So our target is that we only want to deploy firewall policies. To do so, we will use here transparent firewall. Transparent firewall is configured between lane and gateway. Between lane and gateway. Then gateway connectivity with lane is removed. Now traffic will go via firewall using port number 1 and port number 2. At this firewall, we have configured policies. So with the help of transparent firewall, we can deploy firewall policy without changing network. Here, we have not removed router, nothing to do with IP addressing, routing, netting, VPN and MPLS, no change in lane side, no changes in gateway side. Still, we have deployed firewall policy with the help of transparent firewall. So any organization, client or customer who only wants to deploy firewall policy, they can use transparent firewall. This transparent firewall is also called vWire. We also called it vWire, or we also called it bridge mode. Transparent firewall is called by FortiGate and Cisco. vWire is called by FortiGate and Palo Alto. Bridge mode is called by Checkpoint. So Cisco firewall, FortiGate firewall, Palo Alto firewall, Checkpoint firewall, they support bridge mode or vWire or transparent mode. Using transparent firewall, vWire or bridge mode, we can deploy firewall policies in our lane without changing the network. So this is our transparent firewall or virtual wire. Next, we have here HA. What is HA? Let's discuss it. Go to diagram. Suppose we have lane device like PC1, PC2, 3, and 4. Then they are connected with lane. Lane is connected with firewall. Firewall is connected with internet. We have single point of failure at WinLink, single point of failure at firewall, single point of failure at lane link. Okay. Now we can configure here two ISP link. Then we will get here link redundancy. But still at firewall and at inside link, we have single point of failure. So instead of this, we use here two firewalls. We connect both firewall with lane and internet. We also connect one firewall with other firewall. This will be our primary firewall. This will be secondary. Primary will work as active. Secondary will work as here passive. Primary firewall will maintain its configuration. That will be sync with secondary firewall. Primary firewall will also maintain real-time sessions. So they will be sync with secondary firewall. Real-time configuration and session will be shared with secondary firewall. Real-time configuration session will be sync primary to secondary. Now, traffic from our lane will first of all, it will go to primary active firewall, then it will go to internet. If your primary firewall goes down, then secondary firewall will promote itself primary and active. Now traffic will go to new primary active firewall, then it will go to internet. This thing is called here HA. This will be called here HA or failover. With the help of HA or failover, with the help of HA or failover, we group 2 to 4 firewalls. Yes, on FortiGate or in FortiGate HA or failover, we can group 2 to 4 firewall and we can treat them as a single firewall. We will group multiple firewall and we will use them as a single firewall. One will be primary, it means active. Another will be secondary, it means passive. Primary firewall will sync its real-time configuration and session with secondary. First, traffic will go via primary. If primary will goes down, secondary will take over the role. Now traffic will go via new active firewall. This is called HA or failover. On FortiGate firewall, we can configure HA in two types, active passive and active active. Here it is just introduction. What is HA? What we will do? Detailed theory we will cover when its time will come. It means when in sequence HA topic will come, then we will discuss more theory. But here it is just introduction what we will do in HA and types of HA. Next we have here SLB, server load balancing. What is server load balancing? Understand it with the help of diagram. We have a server connected with lane. Lane is connected with firewall. Firewall is connected with internet. And internet is connected with internet user. In this IP of server 192.168.101.10, 192, it is 101.1. Public IP 101.1.100.1.1, 102.1.100. We can use here net. If anyone will hit this public IP 101.1.1.101, then we will translate it with public, or if any public will hit to this public IP, that will be translated with server. So we can achieve this thing with the help of net. But problem is this, suppose this server can handle 10,000 requests, but from internet request will come 40,000. So this single server can't handle such request. Now netting will not help us. Here we will use SLB, server load balancing. In our lane, we will configure or deploy multiple servers like 10, .20, .30, .40. And with the help of SLB, we will distribute the request to multiple backend server like server 1 to server 2 to server 3 and to server 4. Request will come 40,000, 10,000, 10,000, 10,000 and 10,000 in this way. So what is server load balancing? Server load balancing is a feature on FortiGate firewall. So server load balancing is a feature on FortiGate firewall, is available on FortiGate firewall. On Cisco, no. On Palo Alto, no. On Checkpoint, no. It is not available on Cisco Firewall, not available on Palo Alto, not available on Checkpoint. Only on FortiGate Firewall it is available. Okay. Now, with the help of SLB, we can distribute the request to multiple backend server using different load balancing algorithms. So this is our SLB, and SLB is supported for IP version 4 as well as for IP version 6, for IPv4 and IPv6. For both versions it is supported. Yes, for both versions it is supported. Next, what we have? Next, we have here admin profile. What is admin profile? Let's understand it with the help of diagram. This is our diagram. We have a firewall. Firewall connected with LAN. LAN is connected with multiple admins here. Now we have admin 1, we have admin 2, we have admin 3. Okay. Suppose this is L1, this is L2, this is L3. So we will create admin profiles for L1, for L2, and for L1, for L2, and L3. And we will also define their roles. Like L1 can do read-only stuff, L2 can do read-only plus network configuration, and L3 admins can do all configuration. So when L1 admin will join, that can do only the read only. It can see the configuration, but it can't do anything. When L2 admin will log in into the firewall, that can do read only plus network configuration, but it can't configure VPN and another policy. But if L3 admin will log in into firewall, that can do all the stuff. So admin profile, we can define that which admin can do which kind of function or configuration on firewall. So this thing we will cover in admin profile. Next, we have here VRRP. What is VRRP? Let's discuss it with the help of diagram. Suppose we have a lane PC1, 2, 3, and 4. Lane connected with router. Router is connected with internet. And we have another router connected with internet. This is our existing network. Now, on these routers, already we have configured VRRP. Already we have configured VRRP. In VRRP, we configure virtual IP like 192.168.101.1. When we will configure VIP or VRRP here, so router IP like 192.168.101.11, 192.168.101.12, and 101.x, 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 101.x here in this way. 101.x. Done. Okay. Now in VRRP, one router will be master, another will be backup. Lane will send the packet to VIP. Okay, lane will send the packet to VIP. Then traffic will go to master, then it will go to internet. If your master goes down, then backup first traffic will go to master. If your master goes down, in third step, backup will promote itself as master. Then now in fourth step, traffic will go to VIP, but now traffic will go to another master, then it will go to internet. This thing we achieve with the help of VRRP on Cisco routers. This is our existing configuration of any network. Now that company decided instead of router, let's replace router with firewall. FortiGate 1 and here FortiGate 2. Now on these FortiGate they want to same thing. They want to same thing means they want same functionality or configuration. They want first traffic will go they should suppose means traffic should go to firewall 1. If firewall 1 goes down, then that should go to via firewall 2. So yes, FortiGate firewall also support VRRP. In VRRP, we can configure one firewall as master, another as backup. First of all, your traffic will go via master. If your master firewall will goes down, then backup firewall will promote itself as master. Now traffic will go via another master. So just like a router, FortiGate firewall also support VRRP, and VRRP provides us gateway redundancy. Gateway redundancy is achieved with the help of VRRP, and FortiGate firewall also support it. So this thing is our VRRP. Next is ADVPN. What is ADVPN? Definitely we will discuss. We have here ADVPN. What is ADVPN? Let's understand it with the help of diagram. Suppose we have branch 1 connected with internet. Internet is connected with branch 2, branch 3, branch 4. Now we want that these branches should be able to communicate with each other. For this, we will configure here site-to-site VPN. And site-to-site VPN, we need to configure in full mesh. When we will configure site-to-site VPN in full mesh, it will be hard to configure and tissue. Now we want a full mesh VPN solution with easy configuration, and that is our ADVPN. ADVPN is full mesh VPN. In ADVPN, we configure one hub, another as spoke. First of all, each spoke will create a static tunnel with hub. So this will be our static tunnel. Each spoke will register itself with hub and it will create static tunnel. But when one spoke wants to communicate with another spoke, dynamic tunnel will create automatic. Automatic dynamic tunnel will be created between spoke to spoke. So what we are getting here? We are getting here full mesh VPN, which will support dynamic routing like BGP. That will be easy to implement. One time hub config. We have to configure hub one time. One time spoke config. We have to configure spoke one time. Zero touch configuration on hub and old spoke. Zero touch configuration on hub and old spoke while adding new spoke. When we will add new spoke, then nothing to do on hub and old spoke. So this is our ADVPN, Auto Discovery VPN. That is a full mesh VPN, but it is supported on FortiGate firewall. We need all firewalls of FortiGate done. So this is our ADVPN. Next is here dial-up VPN and SSL VPN. So what is dial-up VPN and what is SSL VPN? Let's understand it with the help of diagram. Suppose we have internet connected with FortiGate. FortiGate is connected with switch. Switch is connected with server and client. When client is in office, they can access internal server. But now client is at his or customer or engineer is at his or her home connected with internet. Now when user is connected with internet, it has public IP. Firewall also has public IP. Private lane will use private IP. Public user can access till public, but it can't access private network. But we want user should be able to access internal network. Then we will configure a VPN between PC and firewall. We will configure a VPN between PC and firewall. Using this VPN, user will send traffic to firewall and then it will communicate with internal resources. So this VPN is called here remote access VPN. Remote access VPN can be configured using two protocols like using IPsec or using SSL. When we configure it via IPsec, it is called dial-up VPN. It is called dial-up VPN. When we configure it using SSL protocol, it is called SSL VPN. So remember it, dial-up VPN and SSL VPN. They are actually remote access VPN using IPsec or SSL. This dial-up or SSL enable a remote user so that they can access internal network. Remote user can access internal network of a company via internet. So how we can define? Remote access VPN enable remote user that can access internal network of a company via internet. Remote access VPN will be configured between PC or laptop to firewall via internet, and using that VPN, work from home user can access internal network of a company. And when we will use IPsec, that will be called dial-up. When we will use SSL, that will be called SSL VPN. So this is something about your dial-up VPN and SSL VPN. Next, we have here SD-WAN. What is this? Go to diagram. We have LAN. LAN is connected with firewall. Firewall is connected with internet with multiple links. Now, first we need to define route here. Route 1, route 2, route 3. Route entries 3. Next, policy entries, port number inside to 1 to 2 to 3. 3. When we have multiple internet connection, we need to configure multiple route and multiple policy. Now we want to make this configuration easy. To do so, we will take the help of SD-WAN. We will take the help of SD-WAN. In or with the help of SD-WAN, we will group these physical interface in a single virtual interface, and that interface will be called as SD-WAN interface. Now, how many routes we need to configure? Only one. How many policies we need to configure? One. Now you will say how it is possible. Now we will say here to firewall, if you want to go anywhere, then send the packet to SD-WAN interface. Traffic will go to SD-WAN, then SD-WAN will distribute it over or send the traffic to multiple ISP. So we need to configure only one route. Policy, we will define source like this is our port number 1, 2, 3 and 4. So we will define source is port number 1. Destination is SD-WAN. Action we will define here allow in this way. Done. So we need to configure only one policy, port number 1 to SD-WAN, port number 1 to SD-WAN, one policy we need to configure. So what is the advantage of SD-WAN? SD-WAN is actually a virtual interface which consists physical interfaces or member interface. How many member interface we can configure? Up to 255. So SD-WAN is actually a virtual interface which consists of member interface. We group member interface in a single virtual interface, that is SD-WAN, and advantage is we need to configure one route and one policy that will be applied on all the member interfaces. So this is our SD-WAN. Next, we have here FSSO. What is FSSO or Fortinet single sign-on? Let's understand it with the help of diagram. Diagram is this. We have Active Directory connected with switch. Switch is connected with FortiGate Firewall. FortiGate Firewall is connected with Internet. Now, this is Active Directory or this is Microsoft Active Directory or domain controller. Then what we will do? We will do integration between AD and FortiGate Firewall. That integration is called FSSO. With this integration, for example, there are some groups on AD like HR. They will be sync with firewall. They have group IT that will be sync with firewall. They have group like management that will be sync with firewall and sales. Now on FortiGate, we will define here policy like these source are allowed to access internet. When user belongs to these group, they are allowed to access internet. Now we have a PC. If any HR member will join the domain, AD will tell to FortiGate. If the same user will go to firewall, firewall knows user belongs to HR, allow. If any user from IT will join the domain, AD will tell to firewall user join to IT group. If same user will go to firewall, that is allowed to access. Same way with same thing will happen with management and sale. It means AD users can access internet, but if any non-AD user which doesn't belongs to HR, IT, sales, management, that will go to firewall. Firewall will deny that user. So non-AD user will not be able to access internet. This thing we achieve with the help of FSSO, Fortinet single sign-on, or we can say FortiGate firewall and AD integration is called FSSO. Done. So this is our FSSO. Next, what we have? we have here VDOM. What is VDOM? Let's understand it with the help of diagram. Suppose we have a web hosting company where we have customer 1 server, customer 2 server, customer 3 servers. In this way, we have multiple customer servers. Now, customer is demanding that our server should be protected by firewall. To protect customer 1, customer 2, customer 3 and customer 4 server, we need to purchase 4 firewall. They will be costly. All vendors like FortiGate, Checkpoint, Palo Alto, Cisco, they says that there is no need to purchase multiple physical firewall. Purchase only single physical firewall and create virtual firewalls. So these virtual firewalls are called VDOM or VSX or VSys or security context. VDOM called by FortiGate, VSX called by Checkpoint, VSys called by Palo Alto, security context called by Cisco. FortiGate, Checkpoint, Palo Alto, Cisco. All vendors firewall support virtual firewall called VDOM, VSX, VSys or security context. Who can create? Who can use? Any web hosting company or any company or organization who wants multiple firewall at a single location. So this is our virtual firewall or VDOM or VSX or VSys or security context. Next we have here Ether channel and redundant interface. Understand it with the help of diagram. Suppose we have a firewall connected with switch and connected with hub. Now we are using single interface, they can be goes down. Now we have connected redundantly and we want to bundle them. So we can bundle multiple links. Two approaches we can use here. First one, Ether channel. Another one is redundant interface. Ether channel we can create if opposite devices switch or they support Ether channel. Both device support Ether channel, so we can create here Ether channel. If opposite device is hub that doesn't support any configuration, still we can create here redundant interface. So with the help of port number 1 and 2 belongs to Ether channel, 3 and 4 belongs to redundant interface, and Ether channel when both device support, redundant interface when opposite device doesn't support any configuration, then still we can use here redundant interface. So this thing we can achieve with the help of Ether channel and redundant interface. Next we have another topics are remaining. Okay, today we will keep our course content introduction till Ether channel and redundant interface. Same thing, whatever I have explained with you, same thing I have here in my Excel sheet, weekdays, FortiGate, and now this is not our Hindi batch. This is our English batch. So what we have done? So course content introduction, we have done till Ether channel. So we have done our course content introduction till Ether channel, and remaining topics we will start tomorrow. If you have any question, we can discuss. If not, then see you tomorrow. In previous class, we completed till Ether channel and redundant interface, our course content introduction. Let's move further. Ether channel and redundant interface. Next, we have FortiManage Analyzer and Manager integration. What is this? Let's understand it with the help of diagram. We can configure FortiGate Firewall directly via PC. But in enterprise, what we use? Suppose we have here Firewall 1 connected with internet, and then we have Firewall 2, then we have Firewall 3 and Firewall 4. We use two servers or solutions. First is Forti Analyzer and Forti Manager. We will integrate all firewalls with Analyzer and with Manager. So what is Analyzer? Analyzer is central log collector. Manager is central management server. Analyzer, central log collector. Manager, central management server. So we can send or store the logs of all firewall at single location with Analyzer. And we can manage all the device with a single device. This is called Forti Manager. So here we will learn how to integrate FortiGate Firewall with Analyzer and Manager. So this will be happen here. Next is what? Next we have here SSL decryption. So what is SSL decryption? Let's understand it with the help of diagram. Suppose we have a PC connected with firewall. PC connected with firewall. Firewall is connected with internet, and internet is connected with public server like HTTPS or SSL or TLS. Now user from our lane will establish SSL tunnel with the server, and using this tunnel user will do secure communication. Along with secure communication, user can send and receive virus, spyware, file. There can be data loss. Now we want that firewall should be capable to see inside SSL tunnel. Secure communication should be allowed. Virus, spyware, file transfer, data loss should be blocked. If we want this thing, our firewall should be capable to perform decryption or HTTPS inspection. When we will enable decryption or HTTPS inspection, then firewall can see inside SSL tunnel. Firewall can see inside SSL tunnel, and virus, spyware, file data loss can be stopped. Question is this, is it will work in this way? No. It is only to make you understand that without decryption, firewall will be bypassed. With the help of decryption, firewall can see inside SSL tunnel and we can block the attack. But technically, this single tunnel will be divided into two parts. First will be between client and firewall, and half portion will be between. The single tunnel will be divided into two parts, client to firewall and firewall to. When data is in tunnel, it will be encrypted. When data is in tunnel, that will be encrypted. But when data is available at firewall, that will be in plain text format. So decryption will convert encrypted data into plain text. Then we will deploy here security profiles like antivirus, IPS, application control, while your web filter and sandbox inspection. So this plain text data will be offered to security profiles, and security profiles will clean the data. This clean data can either be downloaded or it can be uploaded. Done. So what is decryption or HTTPS inspection? Decryption or HTTPS inspection convert encrypted data into plain text. The rest of the job is done by the security profiles. Done. So it is just introduction at what is decryption or HTTPS inspection. Detail we will cover when its time will come. Next, we have here application control, or we can deploy here security profiles. With the help of application control, we can control the applications. With the help of antivirus, we will block the virus. With the help of file filter, we can block exe file, PDF file, and other file formats. With the help of web filtering, we can block URLs, and we will also discuss about packet flow. So this is the content which we will cover in this entire training, and this content will be covered in our 22 to 24 sessions. 22 to 24 sessions will be there to cover this entire content. So this was our course content introduction. Next, we have here firewall introduction. Let's understand what is firewall. To understand, okay, FortiGate lab guide, official lab guide, I-MEDITA lab guide, we will share you. I-MEDITA lab guide you will get in hard format via courier. So you need to coordinate with sir or ma'am to whom you are communicating, or who is your accounting manager. Your accounting manager will deliver this lab guide of I-MEDITA at your address. So you need to give address that will come via Indian Post. To understand something, we need to go through with other vendors document. So other vendors documents will not be delivered to you. Those documents you can see at the time of your recording or class sessions, and you can make your own notes. To understand firewall, we need to go through with Cisco documentation. And if you know what is firewall, it is okay. If you don't know, still it is also okay. We are starting from scratch. Now let's start here. So what is firewall? First of all, okay, what is firewall? First of all, let's understand it with the help of diagram. We have PC. We have PC connected with router. PC with router via switch. Router is connected with another router, and another router is connected with its lane like PC2. For easy understanding, let's give IP 192.168.192.168.101.100, 101.1, 192.168.192.168, 1.1, 1.2, 102.1, and 192.168.102.100. So first of all, this is our network. Here we will configure IP addressing and routing. After IP addressing and routing, PC1 and PC2. PC1 will be able to communicate with PC2, and PC2 will be able to communicate with 1. This thing we will achieve after IP addressing and route. Now what we want? We want PC1 should be able to communicate with 2, but 2 should not be able to communicate with 1. To achieve this functionality, we need to add firewall here. We can use one firewall. We can also configure HA here. In HA, we can configure 2. So at this firewall, we will configure policy like source 192.168.101.0 network and destination 192.168.102.0 action allow. Then one piece 101 source can communicate with 102, it should be allowed. Then PC1 will be able to communicate with 2, but 2 will not be able to communicate with 1. So this is the job of firewall. Firewall is a system. It can be a single or group of system. In HA, we can have multiple. Firewall is a system or group of system that manage access between 2 or more network. Yes, firewall will manage access between 2 or more network. Firewall can be hardware. When we are replacing a router with firewall, firewall will be hardware. Firewall can be software. When firewall will be software? When we installed antivirus at PC or antivirus at server, some people call antivirus as a firewall. So firewall can be hardware, can be software, as well as firewall can be virtual appliance in present time. Now, question is this, when firewall will be virtual appliance? To understand this, we need another diagram, but before that, this thing should be clear. Firewall is a system or group of system that manage access between 2 or more network. It can be hardware, can be software, or it can be virtual appliance. So let's discuss when it will be virtual appliance. In present time, we use cloud solutions. Clouds are two type: public cloud, private cloud. In public, we use Google Cloud Platform, Microsoft Azure, Alibaba Cloud, and Amazon Web Service. Private cloud, we can use ESXi server. We can use here VirtualBox. We can use here VMware Workstation. On these public clouds and private cloud, we can deploy our virtual server. And to protect virtual server, we need virtual appliance. Cloud and for private cloud, we can use virtual appliance like for GCP, Azure, Alibaba Cloud, AWS, ESXi, VirtualBox, and VMware Workstation. For these environment, we will use firewall as a virtual appliance. So this thing should be clear what is firewall and types of firewall. This like firewall can be hardware, software, and virtual appliance. Now let's move further. Firewall techniques. Firewall techniques are packet filtering or stateless packet filtering, proxy server, stateful firewall, transparent firewall, and next generation. Let's start with packet filtering. So what is packet filtering? Some people call it packet filtering or stateless packet filtering, or even some call it static packet filtering. So static packet filtering, or stateless packet filtering. In stateless packet filtering or packet filtering, packets are filtered using access list. We use different types of access list, and packets can be filtered based on layer 3 to layer 7. In packet filtering, we will filter the packet. Packet can be filtered layer 3 to layer 7. Types of access list: standard, extended, named, and time-based. So these are the access list type: standard, extended, named, and time-based. Along with it, we can also use dynamic access list, reflexive access list, TCP established access list we can use. Now, so make this thing clear when we are talking about packet filtering. In packet filtering, packet will be filtered based on layer 3 to layer 7, and we can filter packet with standard extended name time base as well as dynamic reflexive and TCP established access list. When we talk about packet filtering, definitely we will get here some advantage like easy to implement and cost effective. How we can say it is easy to implement? Let's understand it. We have a PC with router. So PC is connected with router and router is connected with switch via our server via switch. PC is the source, server is the destination 0 by 0, 0 by 1, in and out, in and out. Okay, packet will in at 0 by 0 and it will be out from the another interface. If server belongs to HTTP, then we need to allow TCP/80. If server belongs to HTTPS, we need to allow 443. Server belongs to SMTP, we need to allow 25 TCP port number. Then, if we know the port, then it is easy to implement. Next, it will be cost effective. So how we can say it will be? How we can say it will be cost effective? This filtering will be done by ACL. ACL can be configured on switch and can be configured on router. If your infrastructure devices like switch and router support ACL, then it will be cost effective. So this is the advantage. This is the advantage of packet filtering, easy to implement and cost effective. Along with advantage, it also has disadvantages like not scalable. So what is the meaning of not scalable? Not scalable meaning is if we have 100 source, 10 destination and 10 services, then question is how many ACL entries we need to create. Formula is multiply source with destination and then service. 100 multiply with 10, 1000 multiply with 10. So we need to create here 10,000 entries. So job of creating 10,000 entries is not easy. So it is not scalable. Next disadvantage, complex access lists are hard to create and maintain. What is the meaning of this line? Let's understand it. We have a PC connected with router, connected with internet. Internet is connected with DNS server. We need to create here ACL. In ACL, we will allow UDP 53. So what will happen? We have a client. Client will send DNS query that will be encapsulated with UDP 53. With UDP 53, packet will go to router, router will check ACL, ACL says allowed. So this DNS query is allowed. But at internet, we also have another server, which is torrent. Now, a user will use torrent data that will be encapsulated under UDP 53 and that will be also here. We only want to allow DNS, but we don't want to allow torrent. So this thing we can't do with the help of ACL. Okay. So with the help of ACL, if you want to create such kind of ACL that when DNS request is going at 53, that should be allowed. And if torrent request is packet or traffic is going at 53, that should be denied. So complex access list we can't create like this, that at UDP 53, torrent should not be allowed. So this is the disadvantage of packet filtering. After knowing advantage and disadvantage, let's move to further, which is proxy server. Let's understand it. What is proxy server? First, we will understand it with the help of diagram. We have a client connected with router, router connected with internet. Okay, 1 minute. And torrent. We have a client in our lane. Client can access Google, can access YouTube, can access torrent. Now, we don't want that user should be able to access YouTube and torrent. To do so, we need to use proxy server. Proxy server we will connect in our lane. At this proxy server, we will define policy like Google, allow, YouTube, deny, torrent, deny. Now, this proxy server will be deployed in two ways. So first method is here, explicit proxy. Explicit proxy. In explicit proxy, we will do client configuration, where client will send request to proxy. Proxy will check the policy Google is allow. Then proxy will send request to Google and Google will give reply to proxy and proxy will give reply to client. Google is allowed. Now client will say to proxy, I want to communicate with YouTube. Proxy will check policy. YouTube is denied. In fourth step, proxy will say to client, YouTube is equal to deny. YouTube is equal to deny. So client can't access YouTube and torrent. In explicit proxy, we will do client configuration. Client will send request to proxy. Proxy will check to policy. If request is allowed, request will go to outside. Reply will come to proxy. And proxy will give reply to client. Next option is here to deploy proxy server is transparent proxy. In transparent proxy, we do gateway configuration. Client will send request to gateway that I am going to Google. Gateway will send request to proxy. Proxy will check policy. Google is allow. Then in fifth step, proxy will send request to Google. Then in sixth step, Google will give reply. Google will give reply to proxy and proxy will give reply to client. So this will happen in transparent proxy. So proxy server will be deployed between client and internet. Two methods, explicit proxy and transparent proxy. In explicit proxy, we will do client configuration. Client will send request to proxy. Proxy will check policy. If it is allowed, request will go to outside. Reply will come to proxy and proxy will give reply to client. In transparent, request will go to gateway. Gateway will send request to proxy. Proxy will check the policy. If it is allowed, proxy will send request to Google or Google will give reply to proxy and proxy will give reply to client. So proxy server can be deployed using two-way explicit proxy or via transparent proxy. So either you are using any method, request will come to proxy and proxy will send it to outside. Whatever I have told you with the help of diagram, same thing is mentioned here. Proxy server. Proxy server works as an intermediate system between inside and outside world. Proxy server will not allow inside user to go outside directly or vice versa. Proxy server is also called application gateway. It is also called application gateway or application firewall. Proxy server is mostly used for URL filtering. URL stands for universal resource locator or uniform resource locator. Limitations can be there, single point of failure. If you are using one proxy, there can be single point of failure. To solve this, use two proxy, primary and secondary. Single point of failure can be solved. It introduced delay. Yes, definitely there will be delay in millisecond. So we can't remove delay here. But yes, we can solve single point of failure. So this was something about proxy server. Next, we have here stateful firewall. Let's start it after break. Let's start with stateful firewall. To understand stateful firewall, we will go through with diagram. This is our topology like PC, firewall, and server. For easy understanding, mention IP addresses. Now, this PC dynamic port will communicate with server like port number 443. First of all, PC will generate a packet. Packet structure will be like this. Source IP 192.168.101.100. Destination IP 192.168.102.100. Source port 1025. Destination port 443. First packet TCP SYN. Such kind of packet will be generated by such kind of packet will be generated by PC, and this will be sent to PC2 firewall. At third step, this firewall is stateful firewall. This firewall in third step, firewall will create a database like 192.168.101.100 went to 102.100. Source port 1025 went to 443. And first is SYN. Such kind of database will be created by firewall. Then in fourth step, packet will be forwarded to server. Now in fifth step, server will give reply like source IP 192.168.102.100, destination IP 192.168.101.100, source port 443, destination port 1025. In the response of SYN plus acknowledgement, such kind of reply packet will be generated by a server and it will come at firewall. Firewall will check 102, 102, port number 443, 443. Going to 101, 101, dynamic port number 1025 matching. Here, layer 3 information is matching. Layer 4 information is matching. Client initiated SYN and server is giving SYN plus ACK. Yes, SYN plus ACK is coming in the response of SYN. So it is the reply of the packet. When layer 3, layer 4 and flags will match with each other, this reply packet will be allowed. If anything is mismatched, then packet will be dropped here. So this is the job of stateful firewall. When a stateful firewall will receive a packet, it will create a database. After creating database, firewall will forward the packet to destination. When reply will come, reply will be matched with its database table. If matching, traffic is allowed, otherwise deny. So whatever I have told you with the help of diagram, same thing is mentioned here, that stateful firewall. Stateful firewall maintain the state of connection when packet is traveling through the firewall. When packet is going through the firewall, it will maintain the state of connection. Stateful firewall maintain the state of connection in state table. After adding information in state table, stateful firewall forwards the packet to actual destination. When stateful firewall receives the reply packet, stateful firewall match reply packet information to its state table. If reply packet match, packet is accepted, otherwise packet drop. If information will match with database, that will be accepted. Reply will be accepted, otherwise drop. Some vendor says it is state table, some call it connection table, some call it session table. This table will maintain source IP, destination IP, source port, destination port, and additional information will be there. So these are the table contents of stateful firewall. Next is what? Transparent firewall. First of all, let's understand it with the help of diagram. Go to diagram. So assume, as I told you yesterday, that we have a client network or company lane. They are connected with the switch. Switch is connected with router. Router is connected with other router via lease line. They can be connected with each other via internet, can be connected with each other via MPLS VPN. Okay, now on router, we will configure first IP addressing, routing, netting, VPN, MPLS. This stuff we will configure here. Now we want to protect our network. To protect network, we will remove router. We will place here firewall. At firewall, we will do IP addressing, routing, netting, VPN, MPLS not applicable. Then we will configure here firewall policies. We don't want to do entire configuration again. We here just want firewall policy. To do so, we will use here transparent firewall. Transparent firewall will be configured between lane and gateway. Connectivity between gateway and lane will be break. Traffic will go through the firewall. Firewall has policies now. So transparent firewall is also called vWire. It is also called bridge mode. Okay. So this is the use case of transparent firewall, vWire and bridge mode. Same thing mentioned here, that what is transparent firewall? It works at layer 2 or it forward the frame based on destination MAC address, but still it has capabilities to filter the traffic from layer 2 to layer 7. It has capability to filter the traffic from layer 2 to layer 7. In other vendors, this functionality is available with same name. Transparent firewall functionality is available with same name or different name like virtual wire or bridge mode. Advantage: with the help of transparent firewall, you can deploy transparent firewall in your network without readdressing surrounding device or without redesign your network. Without changing network, we can deploy transparent firewall in our network. This is the advantage of our transparent firewall. Okay, so what we have learned today? What is firewall? Firewall techniques, packet filtering, proxy server, stateful firewall, transparent firewall. Next generation firewall we have not discussed. Stateless packet filtering, proxy server, stateful firewall, and transparent firewall we have discussed here. Okay, what is next? Next is here next generation firewall, and next generation firewall we will discuss tomorrow.